I would like to introduce you to concept of parallel searching for all 4-node graphlets. There are 6 different 4-node graphlets. We need to calculate combination number of nodes to 4 different cases for each of these graphlets, which is computationally heavy. Instead of calculating, we would calculate combination number of nodes to 3, and then we can use these combinations to find the 4-node cases. The search algorithm is, first we compute 3-node combinations and save them for later use. Then we calculate and save G1 and G2 nodes, which represents 3-node cases. In a loop, we insert one node into G1 cases, and kernel checks its form G3, G4 or G5. And in another loop, we insert one node into G2 cases, and kernel checks if it's from G5, G6, G7 or G8. I'll show you how the algorithm searches for G8 for an example in a small graph. Let's iterate through the G2 cases by inserting a node. After the search, due to the implementation of the algorithm, graphlets may be counted several times. We need to find the unique ones. For instance, G8 will be counted 4 times because it contains 4 different G2s. Dividing the final count by 4 will give us the correct count.
Weisweiler-Neyman kernel is an alternative version for graphlets count algorithm that considers node degrees and color refinement rather than graphlets count in order to create the feature vector. Since it is a kernelized version, it is quick, but we wanted to see the effect of parallelization on it. In order to parallelize it, we first chose edgeless representation, and then we took some random edges out in order to create some subgraphs. Each subgraph was fed into a thread. Then we ran the algorithm for each subgraph, where the thread starts by calculating the node degrees by summing up the values from the surrounding edges, and due to race conditions, a make addition was used. Once they were summed up, we start counting the number of nodes with the same degree values and add it to the feature vector. This is done for n iterations. Overall, even with parallelization, it scaled up almost linearly, indicating the algorithm is already rapid.